everybody. In this experiment, we will be studying the simulation of an SR flip-flop. An SR flip-flop is a basic building block. It is used in many sequential circuits. It is also used in many computer memories. An SR flip-flop has two inputs called set and reset and two outputs called Q and Q bar. In a clocked SR flip-flop, the output changes only at the clock input. The objective of doing this experiment is to understand the functionality of an SR flip-flop and to simulate and implement this SR flip-flop using HDL on a FPGA. This is the block diagram of an SR flip-flop. It contains two AND gate and two NOR gates. And it also contains an SR input as well as a clock input and two outputs Q and Q bar. Coming to the working, now when S equals to 1 and that is S equals to 1 and R equals to 0, at the rising edge of the clock, that is when clock equals to 1, the output of this AND gate will be 1. Therefore, the output of Q bar will be 0. The output of this AND gate will be R is 0 and this clock is 1, so output of this AND gate will be 0. The output of this NOR gate is 1, so Q will be 1. Similarly, at the next instant when R is 1 and S is 0, and for the rising edge of the clock, that is when clock is 1, the output of this AND gate will be 1 and this AND gate is 0. The output of this NOR gate is 0 and this NOR gate is 1. Therefore, Q will be 0 and Q bar is 1. This is the truth table. You see when S equals to 1 and S equals 1 and R equals 0. For the rising edge of the clock, output Q is 1, Q bar is 0. And when for the input S equals 0 and R equals 1, for the rising edge of the clock, that is when clock is 1, Q is 0 and Q bar is 1. And also when S and R both are 0, at the rising edge of the clock, the output doesn't change, it remains in the previous state. And when S and R both are high, it is in a high impedance state. Now coming to the simulation, we will go open a new project, give name SR flip-flop 5, next, finish. New text file. Okay, you have to copy the program, save the program in the same project. The project is srff5. In that I will save it as SR flip-flop.vhd because this is a VHDL program. We have to select VHDL here and give save. Now initially these are the library files. Library IEEE, use library.std_logic 1164, then arithmetic, unsigned, they are all the library files. Then entity, you have two inputs, S and R and clock input, that is basically three inputs, and two outputs Q and Q bar. Coming to the architecture, here we have declared a variable which is used as the input as well as the output, which is output and input. Then see here, if rising edge of the clock, that is for every rising edge of the clock, if S equals to 0, R equals to 0, then temp is equal to temp, that is previous state is maintained. Then if S equals 1 and then if S equals to 0 and R equals 1, temp equals to 0. And if S equals to 1 and R equals to 0, then temp equals to 1. Then when both of them are 1, it is into a high impedance state. Then this variable temp is assigned to Q and not of temp is assigned to Q bar. Now coming to the simulation, we will go for add source. We select the project. The project is SR5. Under that the text is the srff. Then select this. After it gets added, it comes under this. It has to come under this device number, device name. Then select that file. Then give synthesis. It is getting synthesized. It will check for all the errors. If there is any error, if all the syntax are correct, now that there is no error, it gives process synthesis completed successfully. Then select create new source. Give test bench, select test bench waveform in that. Give sr_tbw. Then go to next. Next, finish. The clock is taken as a single clock. Finish. Give the input, that is, for the first clock let both the inputs be low. Second clock make s equals to high, r equals to 0. Third clock r is 1, s is 0. Fourth clock both of them are high. Now save this test bench. Come to the source window. Change source for to behavioral simulation. Then select this srtbw. Come to the process window. In that you have Xilinx ISC simulator. Open that. Double click on simulate behavioral model. See here, during the first clock, when both the inputs are low, that is when s is 0, r is 0, q is 0, q bar is 0. It is maintaining the previous state. Q is 0, q bar was 1. The same thing is maintained when s and r both of them are 0. For that, after this clock, the previous state itself is maintained. In the next clock, we see r is 0, s is 1, r is 0, s is 1. So q is 1, q bar is 0. Next clock, s is 0, r is 1, clock is high, q is 0, q bar is 1. Next clock pulse, both of them are high, q goes to high impedance state. This is the simulation of an SR flip-flop. Thank you.